Hello, everyone. I'm Michael Brooker, and I'm a postdoc at the Ohio State University, working on a public-private partnership that targeted elevated phosphorus fields for conservation practices. Today, we're going to talk about the inspiration behind this project in this module 1, where we seek to identify the risk of phosphorus loss and how it can impact water quality. So briefly, the outline for this first module is going to follow this format. We'll talk about the need to target conservation practices, the relationship of soil test phosphorus to both agronomic and environmental risk. We'll define what critical source areas are, talk about some soil test phosphorus trends in Northwest Ohio, and then how we have gone through this public-private partnership, some of the early results, and how we found these sites that we believe carry greater risk. So conservation practices can be applied across the watershed randomly by finding farmers who are willing to work with you. But we're going to talk about targeting here. The reason we want to target practices is because we believe that there are some fields that have greater risk of phosphorus loss than others. And so you can go about targeting through this design here, where you work with the farmer landowner to assess the risk before getting them to contact a professional, select a BMP, identify a cost share program, and implement the BMP. Now, the issue has been finding the farmers and landowners who know that they have a field that has this risk. And so the way we went about overcoming that barrier is by including nutrient service providers in the public-private partnership. They are this integral role of finding the farmers who have the greatest risk. One of the ways that you can define risk is by looking at the soil test results for phosphorus. Now, here's an example pulled from one of the nutrient service providers, and you can see the number associated with phosphorus. They are highlighted in the flashing red. Numbers between 26 and up to 129. And each of those is assigned a letter grade. Good, low, medium, and then B stands for very good. So in terms of a nutrient service provider, where you have very good, you don't need to apply any more phosphorus. And this is the way that soil test results have been looked at. But what we want to focus on is how this very good phosphorus can actually be very bad for the environmental risk. Because what we see here is below a certain threshold, in this case, that 20 green dashed line shown there, you have a risk to the agronomic yield or the crop yield. In other words, if you have soil test P concentrations below 20, you are at risk of losing out on some of the yield that that field could potentially produce. You want to apply fertilizer so that the crops have something to grow. Between 20 and 40, you start to see that risk really decline. It's not so much any different. So this is the range that we recommend farmers keep their soil test phosphorus concentrations in, between 20 and 40. Now, the issue is that if you go above that 40 parts per million MELIC 3, you start to see that blue line go up. And that's because as greater amounts of phosphorus is stored in the soil, there's also this greater phosphorus loss that you see in the water coming off of that. So again, just focus in on that green line is affecting crop yield, that blue line affecting environmental loads of phosphorus. Numerous studies have been provided that show this relationship between the soil test phosphorus concentration and the amount of phosphorus that comes off the field, both in terms of the concentration at those field sites and how much phosphorus you are losing on a per acre basis. Here, the orange and gray lines representing either concentration or pounds per acre. This paper comes out of Kevin King's work, published in 2017. Other studies have done rainfall simulation tests with soil tests on the x-axis there, and now this blue line showing what would come off of these fields in these bottles. And what you see is that around 110 parts per million, they find this breaking point. In other words, there's a greater potential risk of phosphorus loss if you go above that 110 parts per million. Across Northwest Ohio, many nutrient service providers or ag retailers take these soil tests for the farmers. That data has been shared with Ohio State University researchers, Libby Dayton, who published this paper in 2020, looking at the soil test trends across the different counties. So knowing where they came from, which county, but nothing about the farmer. So it's all aggregate data here. On the left side here, you see 25% of the soil tests are greater than these values as shown here. So up in certain counties, as this one shows, 69, 76 parts per million. At least 1 out of every 4 field has an average soil test phosphorus concentration of that value, which is again above that 40 part per million range. Now, also included in these figures are these STP trends. So if you see it's sort of this lighter red color here, such as the 76, it's decreasing, whereas in red, this value has been seen to increase since 2012. And then, of course, there's not significant or insufficient data. Over here on the right side, then, you see that this is the 95th percentile. And so you see these values are even higher than over there. 5% of the soils in these counties are above this level. And you see some of these getting above 100 parts per million, where you see that inflection point before. So again, we go back to the soil test. From the agronomic standpoint, good, low, medium, very good. But from our standpoint on the conservation side or the environmental side, we want to actually reverse this and think about it in the opposite order. This has very low risk of water quality. This has a very high risk of water quality. So briefly, we want to just talk about what determines the loss of phosphorus from a field. We have the source and the transport, which equals loss together. And in source, we can think about the soil test phosphorus. This is the pool of phosphorus from which you're going to draw into the waterways. So by having a greater amount of soil test phosphorus, you're increasing the potential of loss from that field through the source, or potentially from nutrient additions such as fertilizer application to the fields. The transport is another factor you have to consider. Soil type is going to influence how much phosphorus can be lost. Drainage on the field, whether or not you have subsurface drainage, can affect how much phosphorus gets into the waterways. Management, the cover, ground cover, whether or not you have cover crops or what type of vegetation is growing or crop is growing on the field at that various time of year. And then the distance from that field to the waterway that it eventually gets into. So as that image there on the left shows, water is carrying the nutrients to the edge of the field there. You see the erosion from the surface pathway. What's maybe not shown here in this image is where the tile is actually going on this field. It may or may not have water carrying it underneath the surface of the ground. The STP is up here in this field, then in that soil locked in there. And we know it stratifies, so there's usually a greater concentration of phosphorus at the top that declines as you go down into the subsurface. And for the soil test values, we're talking mostly in the top 8 inches. In the watershed, what we're trying to do is to identify critical source areas for conservation practices. What we know is that by placing practices, which will be talked about in module 3, in these critical source areas, you can end up getting a better, more efficient reduction of phosphorus loss. And so this image here just shows in theory what could potentially factor into this, both in terms of the source and the transport, where here you see very close proximity to water, there might be a greater risk of loss. Whereas soil test phosphorus concentrations that are more elevated than others up here in the fields can also pose a greater risk through this source component. So again, just highlighting this role, soil test phosphorus concentrations are going to impact along with what is happening on the field, whether it's surface losses or subsurface losses, all going to play into how much is actually moving. So now I want to get into this public-private partnership that I brought up when I introduced myself. This is the project that I'm working on. And what we knew at the beginning is that elevated P fields exist. We had that data shared by Libby Dayton showing elevated soil test phosphorus concentrations across the watershed. But the issue was still, how can we find these? So we have me here on the left wanting to monitor these sites, install a practice. We have a farmer here who has a field with high STP, but there's this barrier where I still didn't know them. And to overcome that barrier, we brought in the nutrient service providers, partnered with them because they know these farmers. They're able to interact with the farmers and say, you know, there's this need to put a conservation practice on your field. They also know the individuals who are more likely to respond positively to these conservation efforts. Maybe there's a farmer who doesn't want to be involved in this. They could direct us away from them and help us find the farmers who are more willing to cooperate. This research was really inspired was really promoted by the Ohio Agribusiness Association, who lent their support, wrote letters of support to get this 5-year, $5 million project funded, running from 2018 to 2023 with the likelihood of getting a no-cost extension, extending the project into 2024. You see here we have OSU, we have OSU Extension, we have the Nature Conservancy, and USDA ARS working on this project from the public side, where the private entities are mainly the nutrient service providers and the farmers. Those NSPs share de-identified data with us, which we then combed through, tried to find the fields that we thought were going to have the greatest risk based solely on the soil test phosphorus concentrations. They would then go out, approach the farmers, and ask whether or not they were willing to participate and return that information to us before ever identifying who those farmers were. We only broke that identity once the farmer said, yes, I would be interested in meeting these researchers. Members of our team went out with nutrient service providers, met the farmers together, and talked about what the project was all about. The farmer again said, I wasn't interested. We lost their information. We no longer held on to it and tried to protect their identities as much as possible. For the farmers, there was no cost for the practice. We pay an annual soil testing and give them a stipend. There's also a stipend to the nutrient service providers who are participating in this to try and promote their involvement in our study. As I've alluded to there, privacy is very important with these farmers. There was a lot of uncertainty around the Lake Erie Bill of Rights when this project got started, concerns that by identifying these farmers as owning or working on fields that have elevated soil test phosphorus concentrations could lead to lawsuits against those farmers. So in many cases, you'll see that I do my best to protect the privacy of these farmers, of the nutrient service providers as well, so that anyone involved in this project is unknown to the public. Now, what I want to highlight here is that many times fields don't just get one soil test result. There's actually soil test sampling that goes on in different zones or grids along the field. And in many cases, what you'll find is that there is only 1 or 2 zones in a field that has this elevated soil test phosphorus. It's very rare to find these whole fields here. Up here along this axis, you see 100% of the field, all the zones on that field have elevated STP. The size of these are representative of how many fields fall into there. But what you'll notice here is that most of those fields that are wholly elevated STP have 1 or 2 zones sampled on. And in fact, the majority of fields that you find are going to be in this 1 to 24% range, or really 0% fields that don't have any elevated STP, greater than 100 parts per million. And so you can see that in many cases, it's 1 zone on a field out of maybe 10 zones that were sampled that has this high P. And what that translates to is this image here on the right. The whole field where you see the entire field is above 100 parts per million. And this field actually has 7 zones. It's one of those rare outliers. And then the isolated zone here where you see this zone in the center of the field that's above, just barely above 100 parts per million, and the rest of the field is more in the agronomic range. About 15% of the field we looked at had at least 1 elevated STP zone and were considered for this study. We did consider these isolated zones. As long as that zone was going to flow into a certain point where we could monitor it, we consider that field, but we were obviously favoring these whole fields. So again, just drawing out these examples from lined up to that graph there on the left. So right now I want to talk about field F. This was our initial study site that we found working with a farmer, and this field has 45 acres. You see different soil types across it. It's in a wheat soy rotation. No corn is grown on the site. It does use cover crops. And at the time we met the farmer, he was about to install a new drainage water management structure because the tile had failed at his site. And so he immediately said, yes, next week we're installing this drainage water management structure. You can study our site. It's got a good potential for drainage water management. And we started monitoring it in August of 2019. Going back to those agronomic soil tests that I showed you earlier, this is the example from, again, our nutrient service providers that were provided to us when we first looked at this field. And you see here, you look at this in terms of the risk of agronomic. And in this case, this whole field is blue. All the parts per million of soil test P are above 100 parts per million across the field. It's great. You don't have to apply any fertilizer there. In this case, red would be bad. But we're going to go back to that and talk about how we should be looking at it from an environmental standpoint. Again, when we looked at field F, what we wanted to make sure is that we could capture water coming off the field that was primarily coming from the field itself. And so this is a delineation of the surface water flow at the site run through a PC swim model. And you see the soil test phosphorus values there, this time presented in orange. Again, 100 parts per million up to 400 parts per million here. And you see this delineated area in black where we could install a surface water monitoring. As I mentioned, we had to meet with the farmer, talk about the tiles. He knew where they were on the field because he was doing the work on it to repair the failed system. And the drainage water management structure was installed to the north side of the field because that's the way it exits that field. And again, we know that all the tile on the field comes from pretty much all 45 acres. Just a little bit is not actually contributing to that, mostly in this area up here. Over here on the right, we see the DRP, the dissolved reactive phosphorus concentrations that we've been measuring since August of 2019. And you see that in the tile, this value often exceeds about 0.25 parts per million. And just for reference, in the Great Lakes Water Quality Agreement, we have come to a target of 0.05, or this green dashed line here. You see that most of the time that we are collecting samples from this site, the DRP concentration is exceeding that target. So based on these early results, we think that we made a good choice for our site to establish a best management practice. And this drainage water management structure was installed. For 2 years, we have had to collect data. But just last year, October 2021, we started to control the water at this site. And so we will be getting management data coming from soon. Going back to this soil test P results and how we look at them, what we need to start thinking about is transforming this image here to the risk of phosphorus loss. And so you could just imagine flipping those colors so that instead of blue with the high values, we actually have red with the high values. That means this field has a high potential of losing phosphorus. Now I want to get to more of the results from our other sites, other than just F as shown before. These are the loads that are calculated just off of composite base flow samples. And we do event sampling because we know that phosphorus tends to increase, but this does not include that right now. What we see here, and then this is in range, just so you're aware, from B to L with A and K not shown, but two other fields that we have potentially coming online soon. Decreasing STP. So in other words, site A will have the greatest STP Site K would have the lowest STP across the field in the drainage areas feeding into our monitored sites. And you see the loads coming off this on a per acre, in a pounds per acre basis. And only 3 of these bars, not even F that I just showed you, is above this relatively average loading rate loss in the watershed. So if you just assume that every acre in the Western Lake Erie Basin was exporting the same amount, it would be this green line. So 3 of these sites are obviously very concerning. Some of these sites here in the middle don't look to be that concerning in terms of DRP. And you see that some things change here with the total phosphorus loss from these fields, which is also important. You don't want to just think about DRP. And 4 of these sites exceed. Again, if I include event samples in this, these numbers change. You start to see maybe 4 or 5 here and 6 here exceeding those green target lines. A lot of the reason why this might be happening, though, this middle where you don't see as much phosphorus loading coming, is those other site features, the transport side, not just the source, but what the soil type is, how much water is falling on the site, what the drainage practices are, what the other management practices are at those locations. So to summarize this first learning module, nutrient service providers are a very important link to identifying the risk and conservation practices needed at an agricultural field. Soil test P increases, as well as water movement increases from a site. You're likely to see a greater loss of DRP and TP, and that we believe that as you get above that 100 parts per million STP, you're going to see even greater rates of P loss. So in other words, there's going to be that inflection. For high STP sites, 4R practices have limited to no impact until that soil test phosphorus is going to drop. That likely is going to take decades, so you may have to manage that water in some other way other than just ceasing additional fertilizer application. And so the rest of this module will discuss how nutrient service providers can help increase conservation and adoption of practices in the watershed. So again, I will thank you now, and I appreciate all the questions that I got when I delivered this to the nutrient service providers. Thank you.